What are particles? When you grow up, you will have learned that everything is made up of particles. There are a huge variety of particles that together form the periodic table. In 2020, the periodic table consisted of 118 different elements. But wait, did you catch that? I said elements, but are there other things aside from elements? Elements, which are scientifically known as chemical elements, are the fundamental materials of which all matter is composed. Elements cannot be partitioned into simpler substances other than subatomic particles like atoms or protons and neutrons. However, there are different types of ways that atoms or particles can exist as such, as a compound or a mixture. A compound is two or more fundamental elements that are chemically bonded to form another type of molecule or particle. An example of this is when two hydrogen atoms bond with an oxygen atom to form a water molecule. A mixture is a mix of two or more particles or atoms that are not chemically bonded, so it is easier to separate them. A mixture can be tea because the water and the tea bag mix together. Aside from particles, there is a concept named energy, and it is extremely important when you learn about science. In chemistry, you most likely have been taught that there are three states of matter which are called solids, liquids, and gases. The periodic table's elements divided into these three categories. Which state a particle is in depends on how much energy it has. By now, it is important to say that the six energy stores are kinetic, thermal or internal, nuclear, gravitational potential, elastic potential, and chemical energy. Energy type 1. Kinetic energy can be transformed into other energy stores, which explains why once you eat, you are able to move more because of the energy. If a particle possesses kinetic energy, it is able to move around in its environment. Energy type 2. Thermal or internal, commonly referred to as thermal energy. It is very hard to have kinetic energy without thermal energy, because once a particle is heated, it moves around more because it is warmer. To clarify, thermal energy measures how hot something is, and is tricky to find it without kinetic energy. Energy type 3. Nuclear. This energy type is more complicated, but I'll try my best to summarize it. Nuclear energy is the energy that is found within the nucleus, otherwise known as the core of an atom. As atoms are everywhere, nuclear energy is extremely abundant in the universe. Energy type 4. Gravitational potential. This one is pretty simple. A particle possesses gravitational potential energy when it is high up. A more complex explanation would be that a particle possesses gravitational potential energy because of its position in a gravitational field. Energy type 5. Elastic potential. Elastic potential energy is stored in an object when materials are squashed or stretched. Examples of elastic potential energy include rubber bands or possibly jelly beans. Energy type 6. Chemical. This energy store is arguably the most important type of energy. Chemical energy is stored in bonds of atoms or molecules. When you eat something, you break the bonds, and therefore release chemical energy, which is mostly transferred into the kinetic energy store to let you move. What are the states of matter? Like I stated earlier, the states of matter are solids, liquids, and gases. When a particle is heated, it gains more thermal energy, and it therefore moves around more. The further that particles get from each other, the warmer they are. A simple example of this is water. Conveniently, water can exist as either ice, water, or water vapor. On our planet, you may have also noticed that as you melt an ice cube, it turns into a liquid, and then after further heating, the water transforms into a gas. To summarize, the hotter an object is, the further the particles get from each other, and the weaker gravitational attraction they have. I hope you enjoyed this chemistry video. See you next time. Bye.